coming. My name is Bojan Skaljak. I'm a senior developer technologies engineer from Nvidia. And today I will be talking a little bit about how you can improve your applications with the VRWorks and Ansel plugins in Unity. So this is our talk overview. First, we're going to discuss a little bit what are the key VR rendering challenges. And then we're going to look into some solutions that are provided by the VRWorks plugin and the graphics features. So we're going to talk a little bit about multi-resolution shading, lens match shading, single-pass stereo, and VR SLI. After that, we're going to focus on some details about VRWorks plugin implementation. Then we're going to talk about shortly about Ansel plugin, and at the end, we have a desktop multi-resolution shading demo and Ansel demo, which I'm going to show to you. So, what are the key VR rendering challenges? Obviously, when we are rendering VR, there are two eyes, and we need to render both left and right eyes at the same time, right? So we clearly want to avoid wasting time on CPU and calling the scene twice, but we also want to avoid wasting time on a GPU, so we don't want to render each geometry twice, right? So that's one of the key challenges when it comes to VR rendering. The other challenge comes from the actual lens distortion. So if you look at images here at the bottom, on the left side, we have a standard image rendered by the GPU, right, which is normally a rectangular shape, which is mapped onto your monitor. But the problem is with the HMDs, we actually need a distorted view, which is actually matching the lens. So in this scenario, as you can see on this bottom right image, we get to distort the final image to better match the lens. And as a result of that process, we have all these pixels which are marked in red as complete waste, because they don't actually get projected on the HMD and the user never sees them. So that's another key challenge when it comes to VR rendering. So let's summarize here on this slide. So the first, number one, is how do we render both eyes in a single pass? And the second challenge is how do we reduce pixel waste caused by the lens distortion. So let's have a look first at into the single-pass stereo rendering, which allows us to process geometry more efficiently in VR scenarios. So first, with traditional stereo rendering, right, we require two geometry passes. This is obviously not a good solution, right? We have to render a left eye first, then we have to render the right eye, and most of the modern engines like Unity, they solve this problem on the CPU side by using a single frustum, which is a little bit bigger, so they don't have to cull the scene twice. But on the GPU side, the geometry still has to be processed twice, which is really bad. Now, some of the engines used instance rendering, but that really doesn't help much. It only reduces the amount of time you spend on a CPU by issuing a single draw call. On a GPU side, you still have to process both meshes basically twice. So this is where the single-pass stereo or feature or simultaneous projection feature, which is actually available on a Pascal GPU, comes in very handy. So what happens really is that we render left and right eye in single geometry pass. Now this is actually a hardware accelerated feature. What this means that all the vertex buffers and all the vertex attributes and everything that's associated with processing the geometry before the rasterizer kicks in and pixel shader kicks in, it's basically can be reused for the right eye. So we only end up at the end basically only executing pixel shader twice, and all other geometry-related processing on a GPU happens only once, which makes it much more efficient in a VR scenarios. And like I said, this feature is available on a Pascal GPU architecture. The other feature which allows us to process geometry more efficiently is a VR SLI, right? So like we said, in VR cases, we have to render image twice because we have two eyes, like left and right. So it's kind of logical that if we have two GPUs, you can use them in a more optimal way. So this is basically what we call a normal SLI, and I guess most of developers are familiar with the alternate frame rendering, which has been around for many, many years. And that's where the CPU prepares frame n, and the GPU 0 renders the frame number n, and the GPU 1 renders the frame number n plus 1, and so on. So this basically can increase the performance, but it's actually adding to the latency. And we all know in a VR scenario, adding latency is very bad, right? That ends up with discomfort for most of the humans, and it's a very bad experience if we add latency in a VR scenarios. So much better way of utilizing an SLI that each GPU actually renders separate eye. So what happens is CPU still prepares frame n, and then GPU 0 takes over, renders the left eye, GPU 1 renders the right eye. So this happens in parallel, so we are basically processing all the geometry at the same time, and we get to the display much faster. Therefore, we are actually reducing latency. So single pass stereo and VR SLI, they basically help us process geometry much more efficiently on the Nvidia hardware. Now, we're going to focus a little bit on how we can reduce the pixel waste, stuff that we discussed at the beginning. So we already discussed this shortly. So distorted rendering is basically what's needed to match the lens on the HMD devices. So we start with a rendered image that GPU produces on the left, and then the HMD, probably in the driver and down the stack, basically applies some post-processing effect that creates this distorted image. And as we pointed out, all these pixels that are basically black over there, they basically all end up being wasted. So if you actually pay a closer attention what's happening here, and have a look at this area marked with the green circle, you will notice that not much actually changed in that area from moving from the left image to the right. So the resolution more or less stayed the same. The object didn't get distorted that much. So they look very, very similar. But if you pay attention to what happened to this area marked with the red rectangle, it's obvious that everything that's inside of that rectangle gets squashed and occupies much smaller area on the right side. So it's clear from this that we are basically over-rendering the outskirts of the rendering image way too much. So this is where the idea of the multi-resolution shading comes in, right? So the idea is basically to subdivide the viewport area and then render different regions with different pixel density, which is effectively just giving less pixels for that particular area, effectively reducing the resolution. So in this case, we have a simple 3x3 grid, and what happens, the center area of the viewport in the middle stays at the same pixel density, and you can see when it gets translated in the multi-resolution image on the right, you see they are matching. But what happens to the outskirts, we basically assign lower pixel density, and then we end up rendering into a much smaller area in the render target. So our render target still stays the same dimensions, but in this scenario, we actually don't render the pixels which are basically black there on the right. They never get rendered. So we actually end up rendering much smaller image, and which is matching the lens requirement much better. How does this work? Well, this works with the help of the hardware-accelerated fast viewport broadcast, which is available starting with a Maxwell GPU. This is actually done through a custom geometry shader pipeline stage, where we can take a single triangle and we can broadcast it to multiple viewports simultaneously without basically more or less any penalty in performance. And this is the feature that actually allows us to do single pass stereo as well, because we can broadcast triangles to multiple viewports for the left and right eye, and also for splitting the viewport in multiple regions and rendering at different densities. Now, the great thing about multi-resolution is, although the title of the VRWorks is a bit confusing, but multi-resolution actually works in desktop titles as well. So you don't have to be in a VR project or VR scenario in order to use it. And the reason why is that even if you're in desktop game, like non-VR, a racing game or first-person shooter, most of the people are actually focusing on the center of a screen where the action's happening. And because the games are so fast and a lot of things happening very fast, you basically don't really notice if the outskirts of your viewport are actually rendered at a different or lower resolution, right? So here's some performance data from the racing game Distance. It's a Unity game. And you can see the data points here for the GTX 1050, 60, 70, and 80, and this is at 1080p resolution. And you can see that we are basically seeing 20 to 54% performance increase, right? But it's important to notice that because multi-resolution helps reduce pixel waste, this only helps if your game is pixel bound, right? So if you are CPU bound, none of this is going to help you. If you're geometry bound, then single pass stereo VR SLI is going to help. But multi-resolution allows you to render less pixels, and then even if you're not pixel bound, you can add more effects. You can add more post-processing effects that'll make your game look nicer and still process enough pixels not to affect the user experience. So it's a very nice addition to the desktop titles as well. And of course, performance gains are always good. So now this brings us to the second feature which helps us reduce the pixel waste, and that's lens match shading. Now, this feature is specific to Pascal GPU architecture, and the idea is actually very simple. I guess most of you are familiar with the standard projection where you have a camera, you have a frustum that maps a 3D world into a projection plane that is in front of the camera. And this projection plane basically ends up being rendered on a display, right? So the idea here, if you pay attention, this projection plane in front of the camera is actually no longer flat facing the camera. We break it down into 4 different viewports, which are actually on the angle that, if you imagine, that's actually much better matching lens, which is actually an HMD. So that's the idea. And this feature is actually fully hardware accelerated, so this all happens automatically. And there's really not much you need to do to utilize it. So when we actually render something, this is what happens, right? This is the original image. Now, if you imagine on the right side, those are those 4 different viewports that we basically skewed to match the lens. And when they get projected into 2D, this is basically the image you get. And this image is very close to what we need as a distorted view for the lens. And all the black pixels, again, around, they never get rendered. So we basically don't waste pixels for the VR content. Now, unlike multi-resolution shading, this feature is more tailored for the VR because it is trying to match the lens. And with multi-resolution, it can work in desktop because you can specify your viewports however you want and control the resolution and the pixel density. It gives you more flexibility in desktop titles. So this brings us to the actual plugin. The VRWorks is available starting with Unity 2017.1.b2, that's a beta 2, which was released a couple of days ago. So it's implemented as a native Unity plugin. It supports multi-resolution, single-pass stereo, lens match shading, VR SLI, so everything that we discussed up to this point is supported by the plugin. It is DX11 only for now. It supports basic post-processing effects, and it's only for forward rendering, which is mainly used in the VR. It's available for download on the asset store, right? And One note here, because we discussed already that fast geometry shaders and how we broadcast geometry to multiple viewports at the same time. So don't use geometry shaders in Unity unless you really need them. I guess that is not a huge requirement because most of the projects that I've seen in Unity really don't use geometry shaders. I mean, there are ways to solve this problem as well. You just have to manually edit all your geometry shaders, but most of the people don't use them anyway. I just wanted to put a note there that that could be a potential problem. Some main points about the integration. Like I said, it's a native plugin, comes with the graphics plugin VRWorks DLL, 32-bit, 64-bit. It is really simple to integrate. There's only 2 scripts that you need to attach to your camera. They are C# scripts. And then you just use the scripting language to enable, disable the features. So it's like as simple as Nvidia VRWorks is feature available. In this case, we are asking for single pass stereo, and if it is, then you just set it active feature and then disable it at any point in time. So it is that simple to use these features and switch them on and off. The things that get a bit more complicated when it comes to image effects, and the reason why is because if you remember when we are using multi-resolution and lens match shading, we are actually rendering into a small area of the render target. And there are different pixel densities in the area which we are rendering. So if you are doing post-processing, for instance, you're sampling depth, you're going to potentially have some artifacts when you're crossing the boundaries between viewports because of the different pixel densities. So that's why there's some additional attention is needed to make the image effects work better. And also, that's why sometimes the UV remapping is needed and clamping as well, because if the post-processing is working on the entire render target, because in multi-resolution lens match shading, we use a much smaller area, there is no need to process the entire render target. We can clamp it to the area where the actual pixels are. So we have a much faster post-processing. So all the tools you need is in the VRWorks CG Inc. File, with all the API that's needed to transform and do all the stuff that's needed for the image effects. But actually, we have 2 sample projects which are on the asset store, which you can download. So this is the Nvidia Viking Village. This is our modification on Unity's Viking Village demo, where we demonstrate desktop non-VR MRS. And we already, in that project, we have screen space ambient occlusion, global fog, ambient obscurance, and some other effects, I think, which are converted already to work with VRWorks, so you can actually download the project and look how to handle image effects in your project, and you can even reuse those image effects from there. Same applies to the other sample, which is Nvidia VR samples. This is more obviously a VR sample, so there you can see how single pass stereo works, lens match shading, multi-resolution, and even if you have multiple GPUs, you can try the SLI. And also in that project, we have, I believe, screen space ambient occlusion, depth of field, some basic post-processing effects converted, so they work with the VRWorks. So I'm going to give you just one simple example, and this is a screen space ambient occlusion and some snippet from a pixel shader. As you can see, we are sampling a camera depth normal texture and the actual SSAO texture and just doing some calculations with those values. Now, in order for this to work in VRWorks, it's a very simple change. You need to include the VRWorks CG Inc., and then the changes is actually marked in the green rectangles, right? So instead of using directly samplers from Unity, we just call some VRWorks functions that actually do all the work in the background for us. Now, if you're running on a hardware that doesn't support VRWorks, these functions just basically default back to default implementation, and there's no performance penalty or any issues, right, if you're running on an older Nvidia card or an AMD or any other hardware that doesn't support these features. So it is, I would say, reasonably easy and simple to integrate this in your image effects as well. Now, this brings us to the Ansel plugin. So the Ansel is actually a very cool tool that allows you to freeze the frame and capture images in your game or your other projects. It's actually also available to download from the asset store, and integration similar to VRWorks is extremely simple. It's only a single script that you have to attach to your camera, and that's it. Then hit Alt F2, and you are inside of Ansel, as long as obviously you have a latest driver and all the other requirements to use the Ansel. But Ansel basically allows you to have a free camera, so you can freeze and stop the frame in anywhere you want, and look around and take high-resolution screenshots. So you can take 4K, 8K, 20K images. You can apply all kinds of filters. You even have EXR export support. So if you want to play with tone mapping in professional tools, you can actually even do that. Obviously, super resolution. I already said you can run your game in 720p and then start Ansel and say I want a 20K screenshot from this for marketing purposes, and Ansel will do it for you as long as you have obviously enough memory on your system. And of course, it allows 360 capture. So it can be VR as well. It can be left and right eye as well, and you can basically freeze the scene somewhere and then do a 360 capture, and then you can post this on Facebook or whatever. People can actually use the 360 viewers to see your game, right? So how cool it is in a certain section in the game. So it's Ansel, yeah, so this is the Ansel plugin. It is available for download on the asset store right now. And then this brings us to the actual demo. So we're going to be demoing Unity's Viking Village demo, which we modified. This is the actual sample I was talking about earlier that you can download. It is called Nvidia Viking Village demo from the asset store. And here we actually integrated desktop multi-resolution, and also it has Ansel, so you can actually try it out and look at the shaders and everything. And I'm going to just quickly switch to the demo. Oh, this is actually... Actually, I'm not sure why it's not actually showing it on the main screen, unfortunately. I think we have a problem with the projector. Just a second, I don't know if I can fix that. Oh, okay, maybe now it will work. Just a second, I think it's actually not. Unfortunately, it's not letting me show it to you. I think it's not duplicating the display. It's actually I'm not really sure why it's doing this. Okay, that's something. Okay. Okay, that took some time. So this is actually the VRWorks integrated, multi-resolution shading integrated into Viking Village demo. So on the top left, you can see we are now rendering 100% pixels, and multi-resolution is not on, so this is like native rendering. And then if we hit M key, you can see now we are rendering at 72% pixels, and that's now we are using the viewport splits and using different density. Now notice how the center of an image doesn't really change. And now if we go aggressive, you can actually see here on the left, you can see how resolution changed. Now it's not that easy to notice unless I actually toggle it. So if I go from native, one mode, a different mode, you can actually notice it a little bit. But if we start with the multi-resolution on, it will be very hard to notice that it's actually running. And like I said, the performance gains are between 20 to 20, 30, 50 to 50, can go up to 50% depending on your scene. As I said, integration is pretty simple. This demo is available for download, and you can check it out with all the assets, shaders, and everything, and integrate it in your projects. Okay, and so that brings us to the final slide. Right, okay, that's working. So that's it. If you have any questions, you can email unitysupport@nvidia.com. Also, there's a website, developer.nvidia.com/VRWorks. You can get more information. Again, you can go to the Unity Asset Store and download the projects and have a look, how everything works. And now if you have any questions, we have 3 minutes left. So if there's any questions, I'm more than happy to answer. Oh, can you please just go to, there's microphones here, so everybody can hear. Otherwise, it's hard. No, people don't understand what the question was.
Not that much of a question.
Sure.
But Ansel's it's going to be available 2017B, or is it available now?
Ansel has actually been available for a while.
Okay.
That's for the VRWorks is 2017.1. That's only for VRWorks. Ansel you can use even in 5.6 or even 5.4 should work. Yeah, because it didn't require any changes in the engine itself to work. For VRWorks, we had to work with Unity to make some modifications. So that's why the latest beta is required.
Is there any way to use Ansel for video?
For video?
For capturing video?
Not at this point, I think. I'm not 100% sure about that. I'll have to double check. But you can also try it out yourself. I think at this point we don't have a direct video, but we do have as a part of the GeForce driver, we actually have a feature that allows you to record your sessions and post them, and we've had that in a GeForce driver for a long, long time. So all you have to do is install the latest GeForce driver, and then you can actually record and stream your sessions. So that's really unrelated to the Ansel, but we have that. We had this functionality for a long time. Any other questions? Oh. Sorry, which one? The video capture is for the GeForce driver. I don't think so. I don't think so. We do have some work going on with that in some titles. I'm not really sure where that stands, but that's something like that is coming along. It might be also already available, but I'm not working on that, so I can't give you a 100% correct answer there. But. Any other questions? Or?
The single pass stereo, is that limited just to 2 cameras? or two perspectives?
Sorry, what was that?
The single pass stereo
Yes.
rendering, is that limited just to two?
There's only one camera.
Right, okay.
There's only one camera. So that's what, with a single pass stereo, even with a multi-resolution shading, there's only one camera in Unity, right, which renders the scene. Then nothing changed there. So what happens is that the plugin actually, we modify all the shaders in Unity to output homogeneous coordinates for the left and the right eye. So then setup in Unity is exactly the same, only the shaders change. And then when the shader executes, the hardware takes over and distributes the geometry to left and right eye and renders them at the same time.
So that helps allow for the single pass rendering. Typically with VR apps, you sometimes have a viewer on the desktop like monitor for spectators or anyone else outside of the VR.
Yes, that's not part of this plugin. What you're talking about, I believe, is simultaneous projection on multiple monitors. It's the same technology which is used here. It's just we haven't implemented that particular scenario in Unity yet. That would be maybe in the next version or an extension. So the technology behind is exactly the same. So you would project the geometry to multiple viewports, and in this case, let's say you have 3 different monitors, right? One is in front of you, and 2 of them are like 45-degree angle. You would, in that case, yes, you would need 3 cameras. You would have 3 different viewports, and then you would be able to project the geometry, whatever overlaps or whatever you don't have to render it. Obviously, you wouldn't render it 3 times, right? Which is what you need to do before this feature was added to Pascal.
So now with Pascal, you don't have to render it 3 times? Or?
Yes, but it's unfortunately the VRWorks plugin doesn't have that. So if you want a simultaneous projection on multiple monitors and stuff, that's something they'll need to be either coded manually, or we would need to add this as an extension to the plugin in the future. Okay. But I mean, the hardware supports this already. Yes.
So the technology behind what you're doing for VR and the multi-monitor support.
Yes, it is basically the same technology, right? And if you think about it, it makes sense, right? Whether you're rendering left eye and right eye, you can consider that to be 2 different monitors, right? Rendering. So it's just a VR-specific solution that we have here.
Just sorry to keep hammering on this. So with VR now, without, sorry, what is the phrase for this technology? Single pass?
Simultaneous projection?
Simultaneous projection. So without that, typically with cards or GeForce cards prior to Pascal, you would have 2 passes. Now you do it in 1 pass.
Yes, you would need to have multiple passes, or what people used to do, they would make a really wide frustum and with a really huge resolution, and then they would map that to 3 monitors, but that's completely wrong because it doesn't really match your setup of your monitors, right? They're not flat in front of you, they're on angle, and with the simultaneous projection, you can actually control that much better, right?
Thank you so much.
No problem. I think we are run out of time, so. But if you have any additional questions, you can just email unitysupport@nvidia.com, so we're happy to answer. Thank you.